If you are a startup looking to grow in Cambridge, the Bradfield Centre offers a range of flexible membership packages which put you in control of your office and home working mix. There's a vibrant, collaborative atmosphere, on-site cafe, plenty of green outside space, and regular member social events. For more information, visit bradfieldcentre.com or call 01223 919 600.
Welcome to the Cambridge Tech Podcast, talking all things technology from the heart of the UK's tech capital. Here are your hosts, Faye Holland and James Parton.
I'm Faye.
And I'm James. Joining us today is Ramsey Faragher, who's the CTO of FocalPoint Positioning, a fast-growing Cambridge deep tech company that recently announced a strategic investment from GM Ventures. Ramsey, thanks for taking the time to come on to speak to us today. Very much appreciated. Why don't we begin with getting to know you a little bit better and your path to becoming CTO?
Sure. So I did my undergrad and PhD here in Cambridge in physics. That's where I started to really get my thirst for solving problems and trying to do things that other people haven't done before on the kind of technology front. After my PhD, I went into the defense sector for a while, which was incredible fun. And I got to do things that I wouldn't be able to do anywhere else apart from that sector. So I've worked on the navigation systems of a nuclear submarine, a Martian rover, various airborne platforms, technologies to keep soldiers safe on the battlefield and things like that. That was a really, really interesting time. I don't think I could have worked on as many things in my entire life as I worked on sort of in those 6 years. And that actually culminated in Top Gear magazine labelling me the real-life Q from James Bond, which, just like everything they do, was barely attached to anything truthful at all, but it made a brilliant story, I suppose.
Yeah.
And then I came back to academia for a while, and I was here in the computer laboratory doing AI on smartphones for navigation before people were labelling everything they were doing as AI. So this was a smartphone app that learned for itself the layouts of rooms and where the Wi-Fi access points were and how the signals are bouncing around and things like that in order to map how you move through a building and at the same time learn what the building layout was and things like that. And during that time, as an academic, I was able to talk to the people that make the chips inside the phones and the people that make the operating systems and find out from them what their real problems were in a manner that they don't normally sort of expose what their challenges are publicly, but to academics at top institutions, they're quite happy to ask them for help. And through that, I learned stuff about how the chips are designed. I learned about the real problems that the devices had. And the stars all started to align for me in terms of seeing that I could actually change how the chips inside the phones work in order to solve some big problems. And it rooted all the way back to my PhD and the problem I was solving during my PhD thesis. And the technology that FocalPoint has developed basically roots all the way back to me trying to solve this problem as a 20-year-old that I've now sort of solved as a 40-year-old, and I'm getting out there into all the phones. So it's been like a bit of a life's work accidentally in some ways that I found myself running a company that is making GPS better. I never planned to do that from the beginning, but it just shows how sort of the sequence of events you can go on through your career ends up in a place that you never predicted you would be 20 years ago.
And just spotting an opportunity, I guess, to add some real value.
Yeah, it's the sort of thing that just couldn't have been done in the past. What we're doing relies on how the chips are designed now and the fact that there's lots of sensors in smartphones and in smartwatches.
Yeah.
And you just couldn't have done what we do now, say 10 years ago. The chips were just not designed in a way that would support how we improve them now.
So can you tell us a little bit more then about the technology and what has changed?
Sure. So what we've done is we've solved the problem of being able to determine when signals come from the GPS satellite to your receiver in your phone or your watch or your car. We can determine whether they traveled in a straight line directly from the satellite or if they've bounced off something and come from the wrong direction. And before supercorrelation, that was not possible without very expensive antennas. So normally when you go out for a run or drive around in your car and you go into London and the positioning can be really bad and it can put you in the wrong street or say that you're charging straight through a building or straight through the Thames, it's because the signals are bounced around and the maths inside the chip are using signals that are too long and that pushes you into the wrong position. Basically, the path length is too long when the signals bounce around. And then the technology I've invented allows you to actually image the direction that the signals are coming from. And so for every satellite, you can just simply determine if it's truly coming from the satellite in that azimuth and elevation, or if it's reflected and is coming from the wrong place. And so we can throw away the garbage, keep the good stuff. And it means that even in the most difficult environments in cities surrounded by tall buildings, we give very accurate positioning. And it's the accuracy, the sensitivity, and that level of trust that we improve in a receiver. So the measurements are now much more truthful than they were before. And to you and me, as we use the device, that just means the blue dot's in the right place. But for something like an autonomous car, having truthful measurements is very important. If the measurements are wrong and you don't know they're wrong, then they pollute the rest of the system and can cause completely unwanted effects just because the blue dot's in slightly the wrong place.
So this is called GNSS, right? Rather than GPS.
So GNSS stands for Global Navigation Satellite System, and it refers to any satellite constellation that's used for positioning.
Okay.
GPS is Global Positioning System, and that's the American version. So GPS is American, GLONASS is a Russian system, Europe has Galileo, and China has a system called Beidou. So when you first bought your first sat-nav many years ago and you sat on your drive waiting for it to start so you could go on your journey, there were only about 25 satellites in the sky. Nowadays, there's about 120 satellites up there that all of our phones and cars and watches are using to work out where they are.
So it's the technology that's on the chip that you've developed that's making the change, but also it must be because there are more satellites and more data and those. So what's that balance?
There's been steady improvements over the last 20 years in all of these global navigation satellite systems. There's been countries putting up new ones and countries improving the signal quality and the type of signal they're broadcasting and things like that. So there's always been these improvements going on. But our improvement is a software change that can go inside the chip and improve the performance way beyond the changes to the signal structure or anything like that. It's actually the equivalent of putting a $10,000 military-only controlled radiation pattern antenna, which is the size of a dinner plate, on your smartphone or on your car. These things are military receivers that do the same thing. They can determine the angle of arrival. So they keep the good stuff and they throw away the garbage. And they ignore spoofers. They ignore illegal broadcasts of fake data. So your choice is either be a military platform who's allowed to buy those things, or license our technology and tweak the software and get the same performance benefits for a bit of clever code instead.
And I'm guessing you've worked really hard to understand the kind of compute and battery implications for doing these kinds of things versus, the more traditional GPS.
Yeah, so there's a little bit more software running. We do use a little bit more compute and memory, but it's a tiny fraction of the total that is normally used by the receiver when it actually first turns on and searches for the satellites. So all GPS receivers have to go through this aggressive search at the beginning of looking for the signals, locking onto them and using them. And so there's already plenty of compute and memory to do that bit. So there doesn't have to be any hardware changes at all. And while running some more algorithms in a like-for-like comparison would use a little bit more battery life, what we're actually finding on some of our trials is that there are things we can do that mean you can add in our technology and improve the battery performance because you don't need a GPS fix as often if the fixes are very good. So a good example is a sports watch. So today, if you go for a run with a sports watch and you're trying to determine if you've beaten your PB and where you've gone and all that kind of stuff, your GPS chip on your watch might be giving you a fix once a second. So you're getting these dots on a map once a second, highlighting where you've gone on your run. What we can do by boosting the performance of that position fix and the accuracy and the trustability is we can reduce that update rate to something like once every 5 seconds or once every 10 seconds and fill in the gaps with our own human motion modeling technology, which uses the accelerometers and gyroscopes in the watch. And that's less processing power than GPS. So we can actually provide a much more accurate line on the map at lower battery consumption by bringing these new technologies into play, which kind of balance the battery-thirsty components, which is the GPS processing, with the much lighter touch stuff, which is using the accelerometers and the gyros.
So you've given us a few examples of use cases for this. I'm curious to understand what your kind of go-to-market strategy is. Are you selling to the hardware manufacturers, or are you also trying to build a consumer-facing brand and actually control the kind of use case application end of things as well?
Yeah, so this was a really important decision really early on when I started the company. My PhD was funded by Cambridge Positioning Systems. During my time in academia, I worked with CSR, who have now become or were bought by Qualcomm. And of course, in Cambridge, who doesn't know people who work for ARM, right? So I was highly aware of the business models that have been used on the Cambridge scene in the past for GPS technologies, radio positioning technologies, licensing entities, and so on. And I had a feeling, and I think I was right, that it was the wrong era to start up a chip business and do another CSR. And of course, through COVID, we have just seen huge problems with chipset supply. Yeah. So I can't pretend to have had a crystal ball. I think I was just lucky. But I'm glad I didn't go down the chipset road. So we're a B2B enterprise who licenses our IP. From the very, very, very beginning, I knew it was all going to be about IP and licensing and protecting that well. And in the GPS world, that has often been the case, that some of the most important changes and innovations have been basically a very clever idea that's been patented, got into standards, or otherwise made into a sort of universal technology. And so that's the bit I was trying to ensure we did well and could emulate, that we'd have this strong patent portfolio which gave us good defenses against anyone trying to copy us or invent anything similar to it, and that we would license that IP. So we do work directly with both the chipset companies and the people that go and buy those chipsets. And depending on the application, sometimes our software needs to go inside the chipset. Sometimes it can sit one notch higher and go inside the sort of brain of the autonomous car or inside the operating system of the watch. And so we work with both. The chipset company is, of course, the source of our information. So they at least have to be compliant with our API and pass the data up. And what we fundamentally do is we collect the lowest level measurements that happen inside the phone, effectively the samples of the radio data, and we heal them, and we throw away the garbage, and we sort of sharpen the focus on the line of sight signal, which is why we're called FocalPoint. And then we sort of give the much cleaner, much sharper measurements back to the chip to then process. So we're like a little magic box that goes inside the chip and cleans up all of its data.
It's another bumper news issue this week with key highlights from Forefront RF, Fetch AI, Opto Biosystems, the University of Cambridge, TTP, IQGEA, Featurespace and Luminance. So let's get started. Forefront RF has raised £6.7 million to support its continued disruption of the global radio frequency market for mobile technologies. BGF provided £3.75 million follow-on investment into Forefront alongside existing backers Science Creates Ventures and Foresight Group. Forefront RF, headquartered at St John's Innovation Centre in Cambridge, is a fabless semiconductor company established to make multi-band smartphones, wearables and IoT devices simpler to design and more globally accessible. The company is chaired by Cambridge Angel and former Cambridge Silicon Radio CEO Phil O'Donovan, and we're hoping to get them all on the podcast soon. DWF Labs, a technology incubator with operations worldwide, has revealed a $40 million investment in Fetch.ai, a Cambridge-rooted platform that powers peer-to-peer applications with automation and AI capabilities. Cambridge startup Opto Biosystems, which is developing groundbreaking technology that improves the lives of people suffering from neurological disorders, has officially launched with a $1.85 million pre-seed round. Opto is led and co-founded by former medical device engineer and bioelectronics researcher Ben Woodington, electrical engineer turned neuro-oncology researcher Elijah Jenkins, who both undertook their PhDs in the bioelectronics laboratory at the University of Cambridge. Still at the University of Cambridge, researchers have developed a new type of neural implant that could restore limb function to amputees and others who have lost the use of their arms or legs. Cambridge Enterprise, the university's technology transfer arm, has filed a patent application on the technology and is supporting ongoing commercialisation. In another office move expansion story this week, the Technology Partnership, TTP, Europe's largest independent tech consultancy, is moving into a purpose-built tech campus. A strong cash position allied to expectation-busting growth in revenues, profits and cash flows marked a super year for IQGEA Group to December 31st. The company is cashing in on surging investment, especially in the US, in fibre optic networks and grid modernisation. as it delivers its cutting-edge software for the telecoms and utility industries. Cambridge company Featurespace, whose machine learning technology fights online financial fraud, was named as one of the winners of an inaugural transatlantic crime-busting competition at President Biden's second Summit for Democracy. Ronet, one of South Africa's largest industrial groups, has adopted Cambridge company Luminence's AI to enhance contract and knowledge management across its subsidiaries. And that's this week's news, courtesy of Business Weekly. Now, let's pick back up with Ramsey at FocalPoint. There's obviously an opportunity here for tackling cybercrime. So what can you do? What's the anti-spoofing functionality that you can offer there as well?
Spoofing is when someone pretends to be something else. And so in the radio domain, when people are spoofing GPS, it's that they've bought a transmitter that they've programmed to broadcast the same information that the satellites are broadcasting, and then they fiddle with its content so that they can basically trick a receiver into thinking it's somewhere else. And you can extend beyond GPS, and you can spoof mobile phone signals, you could spoof Wi-Fi. And so these are known problems, all to do with people being able to broadcast the radio data in such a manner that they can trick a receiver. But you can spoof the content of a signal, you can copy what a signal looks like, but you can't break the laws of physics conveniently. And when they transmit that data and the radio waves propagate outwards away from the transmitter, they are moving through space in a certain manner that they can't change. And fundamentally, signals are traveling in a straight line from either the direction you want them to be, i.e. the satellites in the sky, or from that spoofer that's down over there off east of you or whatever, where the satellite is not. And so when you can detect angle of arrival, like we can process the data, determine if satellite number 4, if the signals have come from that particular azimuth and elevation where satellite number 4 truly is in the sky, or if they're coming from that car park over there east of us where they shouldn't be coming from. So we can identify and ignore spoofers by their angle of arrival, which is a very powerful technique. Most of the existing methods to try to determine if spoofing is going on involves cross-referencing with another system, like comparing your GPS fixes with your Wi-Fi fixes, or having a camera that can see if you're traveling down that road, not that road, or having accelerometers and gyroscopes and comparing what the radio measurements say with the sensor measurements. Or you have, as I said before, a very expensive antenna, which is actually a military-only antenna, which also does angle of arrival. And so we're the only way of doing this very robust angle of arrival spoofer detection in software. It's a very powerful capability, and it's not just applicable to GPS. Any radio signal we can process in this way and work out the angle of arrival. So the applications for cybersecurity go way beyond. It's things like preventing someone from pretending to be a mobile phone operator when they're not, or putting up a fake Wi-Fi access point in a location that shouldn't be there. And it's definitely a problem we're going to see getting worse and worse and worse. One of the strangest things we saw in the last few years is that people always talked about GPS spoofing and warned that it might happen and how they might go about it. And there was lots of conference talks on it, a decade ago and so on. And it was even the plot of one of the James Bond films, one of the Pierce Brosnan ones, I think, so a very long time ago, that a British warship was spoofed by the Chinese, and it was the whole plot line of the beginning of the film. So people had always assumed it was either science fiction in Hollywood movies or beyond the realm of what people would do in real life. And then Pokemon Go came along, and normal members of the public were buying on the internet little software-defined radios with a bit of software they could download for free. And they were sticking this thing in their bedrooms and programming it to pretend they were in Paris or Cairo or New York. And they were sitting there with their phone out, getting all of these rare Pokemon in different countries without ever traveling there. The problem with that is the signals were going outside their window and making the ambulance sat outside think it was in Cairo, or making the mobile phone mast at the end of their roads lose its timing lock and stop working. So this has happened now. You can buy spoofers on the internet and use them, and people did, just to cheat at Pokemon Go. We're through the era now of, is it possible to, it's not just possible, it's so cheap people use it to cheat at games. And the bigger concern is what it means for autonomous vehicles and things like that, and why people might spoof autonomous platforms that are not manned. You've got to think that far ahead as to what people might try and use these technologies for. So it's important to have the defences now ready for when people start doing these things in the future.
So I guess my next question is a slight kind of jump back to an earlier question then. We've uncovered like a whole new area of application for the technology. How does the supply-demand model work there? Are you, as the company, coming up with the potential applications of the technologies, or are people coming to you going, could you apply your technology to this? How does that dynamic work?
Certainly a bit of both. We can do R&D on what we've got and test the capabilities that we could provide and then advertise them and go and do the direct showing off of them to try to determine how much interest there is. But then there's a lot of going to various entities and asking them what their problems are and then presenting back to them, we can help with that. And what we've found is that no one has exactly the same problem they're trying to solve. So some people are trying to reduce the cost of their components, and we can help with that for reasons I don't need to get into huge amounts of detail with. But fundamentally, when you're making the system more sensitive, more accurate and better, you can reduce the cost of some of the other components that then dial it back a bit. You could make a device look exactly the same as it did last year, but it's actually got much cheaper components inside it, and our software is kind of compensating for those. You've then got people who just want to improve the sensitivity and the accuracy as much as they can. So they'll want to sell something that is advertising higher levels of accuracy and higher levels of performance. They're the people who are sort of, chasing the gold standard in the market all the time. You've got people who will put a GPS chip in something that's never been put in before and find that it doesn't work because the system is too restrictive. There's no good place for the antenna, or it's a highly metallized object and stuff like this. And we can help boost the sensitivity so that the chip works on that platform and it wouldn't work normally and things like that. And there's also a lot of interest at the moment in using the reflected signals, the non-line of sight signals that are bounced off buildings for positioning. So if you know where all the buildings are, then instead of throwing away the reflected signals, you can work out what the extra path length must have been, carry on doing the maths. And then you go from having only, say, 6 or 8 line of sight signals available to you to having like 120 line of sight plus non-line of sight reflected signals from all over the place available to you. And we're still yet to fully understand just how good positioning can get when you add in all of those reflected signals. And Google have publicly talked quite a lot about how much they're interested in using the non-line of sight signals. And there's a guy called Frank van Diggelen who actually was the inventor of one of the core technologies within GPS chips and phones today. He works at Google and is the president of the Institute of Navigation in the US. And he's given a number of talks on the work he's doing at Google to try to use reflected signals to boost the positioning accuracy in cities. So there's a whole range of things we can help with.
I guess it reminds me of the conversation with Morag at EV, just being very customer focused, having conversations with your customers, as you said, like understanding their pain points, taking that back and informing your roadmap and all those kinds of things. Good advice for anyone listening to this, I think, in terms of just having that open dialogue with your customers all the time.
Yeah, and a key thing I would mention on that point is identifying a champion inside the organizations you're working with who gets it. They understand what you're doing and why you're doing it, are satisfied that it works and it's not smoke and mirrors or fake it till you make it type stuff, but it's real and it's available. And that person then can go and evangelize inside their organization much better than you could ever achieve yourself. We find it very important to have those evangelists inside the other organizations that can take your message and your information, understand it, and go and propagate within their own organization and put their own weight of their kind of reputation and prestige within the organization on your technology and your product. And everything will move much more quickly than you could move on your own when you've got a champion like that.
It's fascinating stuff. Thank you, Ramsey. So let's talk a little bit about the company now, if we can. So where are you up to? What stage are you up to with investment? What are your growth plans?
We're a deep technology company. We needed to change code inside other people's chips and get people to accept that this brand new technology was working and was going to change how GPS works. So it's been a long, slow journey because that bit doesn't happen overnight. So we're 8 years old now. We've just closed our Series C funding round. The first kind of 18 months, 2 years of the company, we're in stealth mode, filing all of our patents. So we were very quiet at first. And then, once we were happy that we had some demonstrators and protected the tech, we could come out on the scene and start evangelizing and finding these champions inside other organizations. And then it was a matter of doing lots of trialing with them and proving that it works on their own technology. It's been quite slow, steady progress, but always sort of heading in the right direction. And the challenge about what we do is that we have a very small number of very high volume customers. There's only one or two chipsets that serve like every smartphone pretty much. And there's only one or two smartphone brands that serve 80% of the people buying smartphones and things like that. And without mentioning names, I'm sure you're figuring out all the sorts of people I'm talking about. And so for our particular business, it's been a matter of working for a long time with these very big famous companies, gradually going through the processes we need to go through with them to convince them to implement our technology. Funding has always been very, very important. We've closed a couple of big deals, but the biggest deals are just ahead of us, I'll put it that way. And they'll be the big deals that take us to profitability. The other issue we have is that we're a licensing and royalties model. And so most of our money comes from the royalties. So when the chip is sold, we take a fraction of that. And it can be anywhere between sort of 1 and 5 years to go from signing the deal where you're in the chip to that chip actually being fully designed, fully built, out the fab, advertised, sold to the OEMs, and then in the market and purchased by an actual customer. And so we certainly have to survive to the point of the royalties as well. So yeah, we've gone through quite a lot of VC funding. We've got very strong backers who understand the story. And we're not one of those companies that can talk about its little hockey stick revenue curve. We're not a SaaS model that can just have this nice little exponential growth from a few hundred users in the first year to hundreds of thousands years later. We sign a piece of paper and we go from being in no phones to being in like 500 million phones by signing the right bit of paper. And not many businesses are like that. And so, yeah, we've been on an interesting journey, and it's my first company, so I don't know any different to this scary business model. But we've got, as I said, we've got a really strong team of investors who understand and can see that, being inside every single GPS chip on the planet through an IP play is very unusual, but very powerful, and will be hugely, hugely profitable when we get those signatures we're out looking for at the moment.
And on those backers, you recently announced an strategic investment from GM Ventures, right? Yeah. And a partnership with General Motors. That sounds exciting. Can you elaborate on that?
Yeah, so that was a really good example of this sort of champion model I was referring to earlier. Yeah. So I was introduced to a key person inside General Motors who's responsible for the performance of the positioning systems for Super Cruise and Ultra Cruise, which is their driver assistance systems. So the hands-off driving capabilities. And the difference between those product names, Super Cruise and Ultra Cruise, is how many roads in the US you can be hands-free for. And so the limiting factors for them are that at the moment they rely on very, very accurate maps. So they've driven around all of these freeways and other sort of open areas and used LiDARs, which are like laser radars, to accurately map the roads and the layout of the street furniture and the buildings to within centimeters. And then all of that is stored in the vehicle, and cameras and other sensors are matching where you are to within the Matrix style, like complicated 3D rendering map of the world. So it's very expensive and it doesn't really scale very well. And, if a new building goes up or there are other changes, the maps change and things like that. That kind of matching is one of the technologies that's used for autonomous driving, but it just doesn't scale to every possible place on the planet where a human can drive. And so how else do you work out where you are to within a few centimeters? Well, GPS can do that as long as there's no buildings reflecting the signals, as long as there's no spoofers around, and so on and so forth. So you can see that link between an expensive technology today that doesn't scale and the holy grail of, if we can just solve this multipath problem in GPS, then we can use that instead, sort of thing. And so, General Motors understand that sort of technological capability. They only invest strategically. And so they saw us as a fantastic strategic partner for their visions in the future of driving. And so, yeah, we were very pleased to close that deal last year and make the announcement at the start of this year. And we are now embarking on a program with them and a certain chipset manufacturer that hopefully will become public in the next few months as to who that is. And we have embarked on a program with them to demonstrate exactly what we can do in helping them solve their problems.
That's just so great for Cambridge and the UK that a UK technology company is solving these problems.
Yeah, I think Cambridge has always punched above its weight globally in many areas. Hopefully we're just going to be another one of those success stories.
Know you brought Cambridge up. What's the setup in Cambridge? What roles have you got here? What type of projects are you running here specifically? And are you anywhere else?
The company is split with its offices between Cambridge and Bristol, and we have people in the States and people in Spain. But our two main offices are here in the UK, and that's very much been historical. So when I first started up the company, I went and grabbed a few of my brightest and best people I'd worked with in the past from my defence days and my days in academia. And some of them were in Bristol and some of them were near Cambridge. And the offices started up simply based on where people were, not based on business units or, manufacturing in one place and development in another, and like that. So we were quite lucky when COVID came along, because most people were sort of quite panicking about how they could suddenly all work remotely. Whereas at FocalPoint from the very beginning, we'd always worked with people in Cambridge and people in Bristol having to work together all day long on the same piece of code or have the same meeting. And so we were always a company with a huge amounts of video conferencing going on. There's about 2/3 of us in Cambridge and about 1/3 in Bristol. And I brought in a CEO, Scott Pomerantz, who's one of the very famous names in GPS. I brought him in last year. He's based in the States. And we've got some business development people who are based in the States and Spain as well.
So we've got a few things to watch out for. We've got the announcement with GM and the big signings on the big contracts. What else is coming up? What else should we be watching out for FocalPoint?
One of the big important steps that occurs in the world of GPS is you've got the sort of normal GPS in your phone today, which is accurate to a few meters. And then you've got the technology that's called RTK, which is accurate to centimeters. And that's used in autonomous vehicles. It's used for precision farming. It's typically a very expensive and very delicate version of GPS, but it gets you that centimeter level positioning. The biggest piece of research that we've got going on right now inside FocalPoint is that we're trying to take our supercorrelation technology, which is based on the meter level accurate stuff in phones, and solve the RTK problem for smartphones. So in other words, we're going to try and get centimeter level accuracy on smartphones using our technology, which will be a very big step up from the performance you get today. So I'm not sure if I'm going to regret saying that now on a on a podcast. It's out there now, so I better get back and crack on with making it work.
Well, thanks so much for taking the time to come and chat to us today. It's been fascinating.
Oh no, it's been a great pleasure. Thank you for having me.
Today's show was produced by Carl Homer of Cambridge TV and supported by our media partner, Business Weekly. The Cambridge Tech Podcast is available on all major podcast platforms and on cambridgetechpodcast.com. If you've enjoyed this podcast, please give it a 5-star review. It will really help others discover the show. High-performance computing and AI is being used to positively transform society and mitigate climate change. KO Data's 100% renewably powered data centres support the mission-critical workloads of life sciences, biotech and AI startups in Cambridge. Find out how we can reduce your digital carbon footprint at kodata.com/contact. KO Data, proud to sponsor the Cambridge Tech Podcast.